Good morning or good afternoon, everyone. Today we're going to be talking about writing and evaluating expressions with multiplication and division. So this looks real similar to what we did on Friday, except Friday we were doing adding and subtracting expressions. Today we are doing multiplication and division. So here I have an example to start because it's basically the same stuff, so we're just going to get right to it. This says the farmer's market is selling bags of apples. In every bag there are 3 apples. A says complete the table. So 1 bag would be 3 apples. So 2 bags is going to be 6 apples because each bag has 3 apples. So 3 times 2 is 6. And then 3 bags would be 9 because 3 bags times 3 apples in each bag is 9. 4 times 3 is 12. So here we go. And then number of bags, B. So if B represents the number of bags, we want to write an expression that could represent the total number of apples no matter how many bags there are, and that's going to be 3 times B. And you can look at this pattern and notice that these numbers are always 3 times these numbers. So whatever this is, it's times 3 to get this. So this times 3 equals this. So you could write B times 3, but I'm going to write 3B. And notice I'm writing it with a lowercase b. I don't know why they're using uppercase. Most of the time, variables are lowercase, so I'm using lowercase. And then it says, what if the market had 25 bags of apples to sell? How many apples is that in all? So in this case, the number of bags, so this right here, number of bags is 25. And we're trying to find the total number of apples. Well, instead of continuing our table way down to 25, we could just say we have 25 bags, so B is equal to 25. So we can substitute B in for this guy right here. So 3B, instead of 3 times B, we're going to take 3B, we're going to substitute in for the B, so that's going to be 3 times 25. So that's going to be 75 apples. If a truck arrived that had some number A more apples on it, then how many bags would the clerks use to bag up the apples? So this is wondering if you have a certain number of apples, how many bags do you need? So we can go back up to our table because I think that would help. So in this case it's saying A, some number A apples. A represents the number of apples now. So if we have A representing the number of apples, how can we figure out how many bags that would be? Well, just like before, the number of bags is 1/3 of this, or this divided by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So for this one, we could say, I'm going to zoom in a little bit, as I'm going to write A divided by 3. You could write it not as a fraction, but I'm going to write it as a fraction because I like it that way. So that would be the answer to this as well. So A divided by 3 would be the number of apples. So D says if a truck arrived that had 600 apples on it, how many bags would the clerks use to bag up the apples? So in this case, A is going to represent 600 because it says 600 apples. A represents the number of apples. So this is going to be 600 divided by 3. Instead of A divided by 3, it's 600. We're substituting it in. And that is 200 bags. And how is part D different than part B? Well, obviously the answers are different. In one case, we are trying to solve for, in B, we're solving for apples. I'll just write it here. So B is solving for apples. And part D, this in parentheses so it doesn't look like a variable. And D is solving for the bags. So that's pretty much it. This is just the first example, and really you're just gonna do the same thing, but for other tables. So you can kind of write. I think it's actually helpful maybe to even at the beginning notice how you set a variable for this, for like this column, and then you make an expression for this column. You might just start off by doing this the opposite then. Pick a variable for this column and do the same over here. And that way you have both things that you need right from the get-go before you start answering questions. I'll help get you started on this. You guys are just going to work on exercises 1 through 3, but I have a couple little hints to throw out there. For exercise 1A, this says complete the table, and it says in New York State there's a 5-cent deposit on all carbonated beverages and bottles. When you return the empty can or bottle, you get 5 cents back. So that's a refund. You're getting money back when you send them the bottles. I remember doing this with my grandpa all the time. I don't know why he did it, because I don't think you get that rich doing this, but, this is, sometimes people collect lots of things to get money back for recycling them. So this says refund in dollars. Does a 5 go here? I'll give you a second. Are you going to put 5 here? Are you going to put 5 here? And the answer to that is no. You are not going to put a 5 here. Because if you put a 5 here, that is, I'm getting $5 for every container I give back. I'm not getting $5. I'm getting 5 cents. And so, how many cents are in a dollar? 100. So 5 cents out of 100, that's 5 hundredths. So 0.05. Which means that 2 would be 0.10 hundredths. So 5 hundredths is 5 cents, 1 nickel. 10 hundredths would be 2 nickels. So there you go for that. That can kind of help you get started so you don't do the rest of them kind of totally wrong. And this one is nice and easy because it has $2.50 in dollars, cost of write-in $2.50 in dollars. So that should be pretty nice. And then this last one is kind of it says it's a challenge question. So I'm going to help fill some things in for here, or you can just you can stop here and get started, or you can kind of listen more. This says a pendulum swings through a certain number of cycles in a given time. Owen made a pendulum that swings 12 times every 15 seconds. And then it wants to construct a table showing the number of cycles through which the pendulum swings. Include data for up to 1 minute. Use the last row C for cycles and write an expression for the time it takes for the pendulum to make C cycles. So the two things here that we're worrying about are the swings and the seconds. So to set this up, in my table I would write number of cycles and I would set up time in seconds. Okay, that can get you started. And we already know the very first one would be 12 times in 15 seconds. So you can go ahead and fill that first one in. And then further on, it says at the very bottom, it wants us, at the bottom it says use the last row for C cycles and write the expression for the time it takes for the pendulum to swing. So this is going to be C right here. C represents the number of cycles, and the time is going to be an expression that compares these two things. And I'll give you a hint. It is going to be, the easiest way to write it is as a fraction that you are multiplying. You could also get it as a decimal, but the hint is that this is going to end up a nice fraction times c. So try and figure out what fraction times c can get you the right answers when you're going through this table. But finish the rest of the table and it might help you figure that out. So that's it. So hopefully everything goes well.